For today's notes, you will need in class 61, double check that says part number 3, area of hexagons on the top. All right, we are continuing our work on standard 14, and the focus today is on a shape called a regular polygon. We're going to start with the definition. A regular polygon is a polygon. That means that it has straight sides and corners, and it's closed. That has all congruent sides and all congruent angles. You can write out the word congruent if you prefer. And so if we take a sneak peek down below to this picture, this is an example of a regular polygon if all 5 of these sides are identical and all 5 of these interior angles at the corner are identical. Okay? Regular polygons have what's called a center, which is a point that is equidistant or equal distances, if you want to write that as 2 words, from all of the vertices. The vertices are the corners of the shape. And so when we're looking again at that picture down below, this would be the center point. It's going to be an equal distance from every single one of these corners. Okay? The radius is actually that distance. So we used radius when we were learning about area of circles, but a radius also exists in these regular polygons when we travel from the center of the shape out to the vertex. So in this picture down below, this solid line or this dashed line are both what we would consider radii. They're each a radius of that shape. And then there would be 3 more that we could draw in if we included all of them. Next up is something called the apothem or the apothem. I've heard people say it both ways. That's going to be the distance from that center point still, but instead of traveling to the vertex, we're going to travel to the midpoint of a side. And when we do that, it forms a right angle with that side. That happens because if we're going from the center to the midpoint of a side, it forces these 2 pieces to be congruent to each other. We already know that our radii are congruent, and then we could use reflexive property to call that side congruent to itself. So it forces these 2 triangles to be congruent triangles, which means these 2 angles have to be congruent angles, so therefore it's a right angle. Okay, so in our picture, this would be the apothem or the apothem. We label that with a lowercase a. Last up, in terms of the parts of these regular polygons, we have what's called a central angle. That's again an angle that's formed at the center of the regular polygon by 2 consecutive radii. So in this picture, this entire angle right here, so in this little triangle that has solid sides but extended all the way back to that radius right there, that's the central angle. So that central angle I'm just going to label by kind of drawing out of that section with a theta. But that whole angle right there is what we're talking about. Okay. For our area of regular polygon problems, you're going to need to know the names of 6 different regular polygons. They are listed right here. So they're named based on the number of sides that they have. Some of these are going to be familiar because you've learned about them in the past, and others might be new. So if a regular polygon has 5 sides, like this one that we've been working on down here, it's called a pentagon. If it has 6 sides, we call it a hexagon. 7-sided regular polygons are called heptagons, H-E-P-T. 8-sided regular polygons are like stop signs. Those are octagons. A 9-sided regular polygon is called a nonagon, and then a 10-sided regular polygon is called a decagon. So what will happen in the problems that you're asked to do in your homework and on your assessments is that there won't be a picture given to you. It will just be described in words, the type of regular polygon you're dealing with. So you're going to need to know that if they say heptagon, that means 7 sides. Or if they say nonagon, it means 9 sides. So you'll need to remember those 6 names for regular polygons. All right, moving into the actual focus for today. Our goal is going to be to find the area of these shapes. And so what happens is we rely on triangles to help us do that. If you look at this situation that we have drawn in this picture, we have a little triangle here. I'm going to actually go ahead and highlight it so we can focus in on it a little bit more carefully. That repeats itself over and over and over in this regular polygon. There are 2 of these per side that are identical. So if we could find the area of this little triangle, we would be able to multiply that by something to fill up that entire regular polygon. So what we notice, if we're thinking about the area of this triangle, is that we have something available to use as its height. That's the apothem we just marked in. And then down here would be the base of this little triangle. And that is going to be half of this side length. So for this little triangle, we would have 1/2 times the apothem times half the side. But then what happens is we multiply by a certain number to fill up the rest of that shape. And a shortcut of doing that is actually to keep the 1/2 and the apothem. So that's the 1/2 and the height. But then the base is really this entire distance all the way around by the time you put all those triangles together. So we might write that as apothem times perimeter divided by 2. Perimeter is the distance all the way around that shape, which puts all those bases together. Or you could write that with a 1/2 out front and then the apothem times the perimeter. Or sometimes what people do, since A represents the apothem and P represents the perimeter, is they substitute in how we actually find the perimeter. So perimeter is found by taking the number of sides and multiplying by the side length. So this N would represent the number of sides in the polygon, and this S would represent the side length. And so sometimes this formula is written either with the 2 on the bottom or the 1/2 in front. That part doesn't really matter, but it's written as A times N times S over 2. Apothem times number of sides times side length divided by 2. Or you could pull that 1/2 and it would be 1/2 A times N times S. This formula right here that I'm going to circle is the one that's on your assessment resource card that you get to use during your assessments, but all of these others are equivalent to that. If you prefer one of those, that's fine. You just need to remember it for yourself when it comes to taking your assessment. Okay, let's go ahead and practice some of that vocabulary, and then when we get to the next page, we'll practice actually using that area formula.